Hello, I'm Henry. Today I will present about Project 14, heart disease prediction. I will talk about introduction. Heart disease including coronary artery disease and myocardial infarction remains one of the leading causes of mortality worldwide. Early detection of individual risks can significantly reduce complication and improve patient outcomes. In recent years, machine learning models have shown strong potential for predicting high risks from patient data, providing actionable insight for medical data. The project focuses on prediction heart disease risks using both real and genetic patient dataset and identifying the key features that combine most to these risks. Let's talk about objective. The primary objective of the project are like to predict likelihoods of heart disease based on patient attributes to evaluate and compare the performance of logistic regression and written forest model to identify and highlight the most significant risks further contribution to heart disease to provide a reproducible workflow using AI Studio for data processing, model trainings, and evaluation. So let's talk about dataset description. Is UCI heart disease dataset. They have like three patient records. A feature include age, sex, chest pain type, blood pressure, fasting blood sugar, resting ECG, reset, maximum heart rate, exercise, ST depression, slope of ST sigmas. And then number or major visits or something target very well like presence of heart disease, 1 equal to yes, 0 equal to no. So talk about methodology. In step one, we have like data processing, had amazing value like using main importation for numerous feature and the model implication for categorical feature. Normalize numerous feature is about minimum maximum scoring or standardization to improve model converge. Encode categorical feature using one-shot encoding. Simply data into training 70% and testing 30% set. For step 2, model training. Logistic regression, like simple and inter-event model, provide probability scores and odd ratio for feature. Banner for us, Acceptable for decision tree, capture non-linear relationship between features. Feature importance can be extracted for analysis. Okay, for step 3, model evaluation, metric, accuracy, uh, precision, recall, and then ROC AUC, like visualization ROC curve for each model, feature importance bar chart. So this is above AI workflow. The first step of the workflow involved importing the UCI heart disease dataset into AI Studio. A SCV important node was used to load the dataset into the workflow. After inputting the dataset was previewed to ensure all columns were correctly recognized and that the data type were appreciated for the future processing. The dataset contained 303 patient recording with features such as age, sex, chest pain type, resting blood pressure, cholesterol, and detected variable indication heart disease presence. After inputting the data set, a new attribute name, rates, rest generate to simplify classification. Using a type column node in AI Studio, like the formula, if target greater than 0, high risk, no risk was applied. This transformation converted to the numeric target value into category level, allowing easier interpretation and visualization of patient risk level. So after generating the category or risk attribute, it was converted to numeric to binomial format to comply with machine learning model. Once the risk column was converted into the binomial format, it was designed as a target variable for the predictive model. So after using the several nodes in AI Studio, the risk column was assigned for the role of lever, indicating that this is the variable to be predicted by machine learning model. Okay, after assigning the risk column as a lever, the select attribute mode node was used to define which patient feature would serve as predictor for machine learning model. So they have like you can see before replace missing value and then after replace missing value. Following the session of feature, a replace missing value node was applied to handle any missing data in the dataset for numerous columns such as age, blood pressure, and then cholesterol. Like missing value were replaced with the means of the representative column. After handling missing value, the numerous features were normalized to ensure they were one comparable scale for the model training. So to evaluate the predictive power or individual feature, the weight by information gain node was applied in AI Studio. This nodes calculate the information gain of each feature relative to the target variable risk, providing a measure of how much each feature contribute to reducing it, uncertainty above heart disease prevalence. So following the weight of the future by information gain is selected by weight nodes was applied to retain only the most predicted attribute for the model train. Okay, the next step is about cross-validation was used to evaluate the random forest model in a robust and reliable manner. Within the cross-validation node, each for all the dataset was used to train a random forest model, which is learn the relationship between patient feature and the risk level. So this is about my finding. Accuracy like 80.45%. So let's talk about conclusion. This project successfully demonstrate the use of the machine learning to predict heart disease risks. The workflow in the AI Studio, including pre-processing, feature selection, random forest training, and cross-validation, produce a reliable predictive model with 18.45 accuracy and 0.886 ROC AUC for the risk feature. Key risk further identified such as the cheese paint type, age, maximum heart rate, provide actionable insight for decision making. Overall, the project highlight the value of data-driven approach in healthcare. Future improvement could include explanation of the dataset, incorporating additional patient feature, and exploring more advanced models such as HGB boost a neural network for to feature enhance prediction performance. So that's all about dataset 14. Thanks for your time.